In this podcast, we're going to be graphing in vertex form. And guess what? We're going to do everything right on this page. So the last one took a while. This one won't. Vertex form, that's a nice form to work with. And we can get it all done on this page. So let's identify first our direction, up or down. Again, all you have to do is look at A. Right, so A is that coefficient in front. And it's in front of not an x squared this time, but, oops, not in front of the something squared. All right, so here A is equal to -1/2. And since A is less than 0, our graph is concave down. Okay, so down. You can write down, actually let's write concave down. Let's be mathematically precise. Concave down. Yep. Our vertex. And so this is vertex form. So our vertex is really, really easy to identify. All right, so just a reminder, so this is what vertex form looks like. We have y equals a times x minus h squared plus k. So our equation is -1/2. We have x plus 3. So that means that that is really x minus a -3. So our vertex is going to be at -3, 4. Axis of symmetry is a vertical line that goes right through the vertex. So that means it's x equals -3. And so actually let's move our axis of symmetry. This one we're not going to change the scale. It should be fine. There we go. To find our y-intercepts, I'm going to change colors here. So you don't really need to write all of this I wrote for vertex form when you're solving problems, because hopefully you'll be able to just, you'll learn how to just identify it from the vertex, right? Once you get the hang of it, you just remember if you see a plus, it's really minus a negative, and then the k is whatever is being added, and that sign doesn't change. All right, so you won't have to keep doing what I just did there for vertex form, but just to help us out, I wrote that in. Let's find the y-intercept. So to find the y-intercept, we just plug in 0 for x. So we have y equals -1/2, 0 plus 3 squared plus 4. So that would be -1/2. That was going to be a 3 squared. And if you don't mind, I'm going to square the 3 at the same time. I don't think 0 plus 3 necessarily needs its own step. So 3 squared is 9 plus 4. I'm going to change that 4 to halves, because eventually, to be able to add these together, I'm going to have to change that 4 to 8 halves. Right? So if you divide 8 by 2, you get 4. 8 halves is the same as 4. So now we'll multiply. So y equals, that's going to be -9 halves, right? Because that's technically 1 as our denominator under an integer, plus 8 halves. So that means our y-intercept, right, we're going to have here, I'll just put y equals, and then we'll put the y-intercept as a point up above. So that's going to be y equals -1/2. So our y-intercept is 0, -1/2. Now we just need our x-intercept. I may have to go sideways. I'll start here, but I may have to go across the graph. All right, so to find our x-intercepts, we're just going to plug in 0 for y. Maybe try someplace to move something to. If I didn't write all this out for vertex form, I'm just going to move this up just a wee bit. Can I get over? There we go. So that's just, I gained a couple inches there. All right, so we just plug in 0 for the y. So we have 0 equals negative 1/2 x plus 3 squared plus 4. Our first step is to subtract 4 from both sides. So we have negative 4 equals negative 1/2 x plus 3 squared. We need to get rid of the negative 1/2. Right? So if we have a fraction, you multiply by the reciprocal. If it's negative, you multiply by the negative reciprocal. So if we flip the 1/2, that becomes a 2. And then if you think about it, 1/2 times 2, you take a half of 2, you got 2 cakes, and you eat a half of them, you're eating 1 cake. All right, so that's just, if I multiply, I'm just going to squeeze it in right here, right? Rather than making a separate step. Let's just squeeze the negative 2 in right to there. All right, so negative 2 times negative 1/2, that's 1. So on this side, we have just x plus 3, x plus 3 squared. There we go. And on that looks just so weird. I hate it when the board extends while I'm writing. X plus 3 squared. On the left-hand side, that's going to be a positive 8. Let's save some space. Right? We know the next step is going to be take a square root of both sides because we're solving for the something squared. So rather than writing this again, I save myself some space. Let's do plus or minus the square root of 8 and plus or minus the square root of x plus 3 squared. I probably should have written that in green just to keep everything in the same color and just made the negative 2's in black. That was my intention. Let's simplify on the left-hand side. Right, so 8, remember, let's put it over here. 8 is 4 times 2, and 4 is 2 times 2. So 1, 2 comes out, 1, 2 goes away. The other 2 is going to stay under the radical because he has nobody. So on the left-hand side, we have plus or minus 2 square roots of 2. Should I add a plus or minus here? Well, that would be wrong because the square and square root are just canceling each other out. I got carried away. There we go. So on the other side, we have just an x plus 3. So now we'll just subtract 3 from both sides. So we have a negative 3 plus or minus 2 square roots of 2 equals x. And you might say, how are you going to graph that? We're going to have to change that to a decimal equivalent. Right? So, but let's write the x-intercept. So technically, right, those x-intercepts would be negative 3 plus 2 square roots of 2, 0. That thing that looks like a squiggle is a square root sign. Maybe I can write it down here and drag it up. So negative 3 plus or minus 2 square roots of 2. Oh, I forgot to write my 0 in. 0 and negative 3. Oops, did I put plus or minus? I wanted to have both of them in there. Let's write them separately. So negative 3 plus 2 square roots of 2. Maybe you should wait till I finish writing before you write anything down. I promise that's not going to change. And negative 3 minus 2 square roots of 2, 0. So those are technically our points. We're going to get decimal equivalents. And I'm really hoping that as I walk to my podium, that I can reach a calculator. I can see a calculator, but it is out of my reach. So I'm going to very, very quickly put you down for a second and go get it. And I'm back. Did you miss me? I'm sure you did. All right, so let's plug this into the calculator, and you can do the same thing. And you can see if you get the same thing as me. All right, so we have, I'm going to take care of the 2 square roots of 2 first. And to do that, I'm going to hit, on my calculator, I'm going to hit the second and get the square root. And then I'm just going to put a 2 in there. And it's very dark in here, by the way. And then I can just multiply that by 2. And actually, if I was thinking, I would have put 2 times 2 square roots of 2, but I didn't. But that's okay. All right, so 2 square roots of 2 I have. So now all I have to do is add a -3 to it. Or just subtract 3. It's the same thing. So the one on the left there, the -3 plus 2 square roots of 2, that's -0.17. We'll just take 3 decimals. So -0.172. So it's approximately -0.1720. All right, so when you're solving, make sure you get the exact answers, and then we can make them decimal equivalents if we're graphing. All right, and so now let's get the other one. So now I want, this time I'm going to remember, -2 times the square root of 2. And that gives me -2.83 approximately. And then we'll we'll subtract or add a -3. So either add -3 or just subtract 3. And I get -5.83. And the nice thing is we know what the shape has to look like. So if there's anything out of whack or parabola looks weird, then we'll know we made an error. But if our parabola looks good, we can feel pretty confident. I really wish it wouldn't look like that. I'm going to rewrite the 0 in. And the thing is a comma. That looks so big. There we go. All right, so let's graph that. I think I'll just graph in red this time. All right, so we have our axis of symmetry already at x equals -3. Let's graph our vertex. That's a nice easy point. -3, 4. So all we have to do is count 4. All right, let's graph our y-intercept. So 0, -1/2. All right, so that's right here. And if we have a point right there, 3, let's actually write the coordinates in there. So this is -3, 4. This was 0, -1/2. So we're also going to have a point 3 this direction. Right, so that would be -6, -1/2. We can use symmetry. All right, now let's get our x-intercepts, and that's actually looking pretty good, right, because our x-intercept was -5.8. All right, so where's that point going to be? Well, we know it's a lot closer to -6 than it is -5, so let's just put it there. My dot's kind of big. That's kind of as best I can do anyhow. Right, so this is our x-intercept, and we'll just write that in as what we graphed, -5.830. And then our other x-intercept was it's just a smidge less than 0 over here. And you can see our points are looking pretty good. And that would be -0.172, approximately 0. So we're not going to give that as an answer when we're solving, but for our graph here we will. And I would have written out the exact answer, but there's almost only so much space on the graph. And so now we can connect our points. If you ever think this is not enough points, you can always plug in another point and get another value. So for instance, what if I plugged in a 1? All right, so if I wanted another point, if I plugged in a 1, so f of 1, I'd have, I don't know if I nicely, -1/2, 1 plus 3 squared plus 4. Let's say I didn't feel comfortable with just those points. You can always plug in an extra value to help you graph. And now, so you're not going to want to plug it in between. You want to plug it. You want to choose a value that's a little further away, so you get a little bit more graph. So, and so we're all kind of like, all these points here are kind of like really close to the x-axis. So maybe you want one that's a little further away from the x-axis. So you can choose something that is greater than, our largest point there was 0. In terms of x was 0. So you can plug in 1, for instance. And that's what I did. So this would be negative 1/2, and so that would be 4 squared plus 4. And maybe it's too big to graph, but let's find out. So this 4 squared is 16. Negative 1/2 times 16 is going to be negative 8. Plus 4, oh, we can easily fit that in. That's just negative 4. So if you want another point, you could plug in, for instance, 1, and then we'd have one more point. So this is the point. I plugged in 1, so this is 1, negative 4. And of course, using symmetry, if you have a point this direction, right, I can count 1, 2, 3, 4 the other way. So this would be, that'd be negative 7, negative 7, negative 4. All right, and I just use the fact that the graph is symmetric to that axis of symmetry. And now I have plenty of points. All right, so not a requirement to get extra points, but if your graph, all your points are really clustered together and you feel like you don't have a whole lot of graph when you graph it, you can always get one more. The domain, remember, is going to be all real numbers, negative infinity to infinity, all the time for the parabola. And the range, right, so all we have to do for the range is look to our vertex. It's pointing down, so it is going to be negative infinity. And then we look to the y-coordinate of the vertex, so the largest y value is 4, because domain is x and range is y. And that's all there is to graphing this graph in vertex form. Thanks for watching. Bye for now.